Okay, so we're just going to make a quick video here on simplifying fractions. You guys have simplified fractions pretty much your entire life, and we'll talk about that in a second, but we'll talk about concepts behind this idea and why it is that we're going to do something in this video the way that we do it. So concepts are this. So you've been asked maybe before for you to simplify a fraction, say like 9/12. So your teacher would say to write that in reduced form. Now, most of you, okay, over a course of time, when you do this, you're like, oh, divide by 3, right? And the reason you're dividing by 3 is okay, you know that there is a number that you could take, okay, and multiply 3 by in the top and 3 by in the bottom, that would make this number 9 and would make this number 12, okay? So in this problem, in the top, if I did 3 times 3, that would get you 9. And if I did 3 times 4, that would get you 12. Now, you guys have learned the shortcut way of doing it. And what that does is it takes away the terminology that I'm going to use. And the terminology I'm going to use is I'm going to do the same thing that we're doing here, except the problem is in a minute we're going to do this with algebraic expressions. We're not doing it with numbers anymore. So in doing it with numbers, this shortcut, okay, is okay. It checks out. But this shortcut, you can't do that when it gets to algebraic expressions. So what we're going to do is we're going to do this option. So we're going to ask ourselves, very similar, right? However, we're going to write it all out. So what this is called, okay, down here, 3 times 3, what these are called is factors. So what we're going to do is we're going to write out the factors of the numerator, and then we're going to write out the factors of the denominator. And then what we recognize is that when a factor in the numerator matches identically something in the denominator, we get to cross a pair out. So 3 and 3 is a pair. I can cross them out. And then lo and behold, what you have is you have the reduced answer to 9/12, which is 3/4. So the most important thing here is we are going to use the concepts of factors. All right? So let's get to it and let's go through the problems. All right, so example 1, it says n plus 1 divided by n squared minus 2n minus 3. So what you have is you have a linear binomial that is being divided by a quadratic. Now, if you didn't watch any of my previous videos, you're at a disadvantage here because I'm not going to talk about how to factor, but I'm going to talk about that they factor. So the bottom, the denominator is a quadratic. Well, I know quadratics potentially, okay, factor into a linear times a linear. And when I factor them, I'm hoping that one of them is going to match my binomial factor that's in the numerator. So n squared. So I split the n's and I get n plus 1. And then basically I'm checking for factors now of -3 because my leading coefficient is 1. I'm looking for factors of -3 that make -2. And in this problem, if you do -3 times +1, you will get -3, but when you add those factors, you will get -2. So what you have now is that you have to understand that quadratics, okay, quadratics have factors, okay, that are linear. Okay, it could be a monomial linear, which means it could just be one linear term. It could be a constant, or it could also be a binomial linear. So what we have here is this n plus 1 is a group, and the bottom here. So what I have is matching n plus 1s. Now, in math, you need to also understand that we're not crossing them out. A lot of people like to use the word cancel here. We are not canceling. We are reducing. So when you reduce something by itself, it turns into 1. So a common mistake here is people like to just write that the final answer to this is n minus 3. And the problem is that's because you're using the word cancel. You're not thinking about reducing. So when you cross this out, this again is not canceling. Okay, this is not called canceling. This is called reducing. And if you look at it, when I strike through it, that looks essentially like a good value for a 1, right? It looks like a big 1 here. All right. So what you need to understand is that that numerator reduces to 1. So my final answer is 1 over n minus 3. So I hope that makes sense, but that's example 1. So what you do here, all right, is you separate it out into its factors. So if you're struggling with this at all, most times that people struggle with these is because they don't know how to factor. So if you don't know how to factor, I suggest going back and checking a look at my video where I talk about factoring quadratics with a leading coefficient of 1, because that's what I'm doing here. All right, on to the next example. Okay, next example says 8r minus 40 over r minus 5. So I didn't talk about it in the first example, I just wanted to get directly into a quadratic, but in this example, I don't have a quadratic up top, okay, and it doesn't mean that, but the very first thing you should always do, okay, when trying to write factors is we factor by GCF. So technically what I should always be looking for, and sometimes we skip over it as teachers because we know the example doesn't have a GCF. Like last example, I didn't mention it, because I look at it and I'm scanning, me personally, I'm always scanning and I'm seeing that there's no GCF. So this one, I wanted to make an example of, when you factor, it could be by GCF. So if you look at the numerator, okay, is 8r minus 40. Now, it's a linear, it's not a quadratic, so it's not going to make two more linears, okay? But if you look at each term in the expression, so 8r and then 40, these two of themselves, okay, have a common divisor. And because they have a common divisor, that is what is said to be their factor. So what number can you multiply to make 8 that you can also use to make 40? And in this case, that is 8 itself. So what I'm going to do is I'm going to factor this by GCF. So the thing that they use is an 8. And basically, how do we make 8r? It's r. How do you make 40? It's negative 5. So that is now factored by GCF. The bottom is r minus 5. So now what happens is I have a linear pair of r minus 5 that they reduce. And now my final answer here is 8 over 1. And 8 over 1 is 8. Let's do one more example. Okay, last example. So this is the last example we're going to go over, which is basically you have two quadratics. So we had a linear and a quadratic, we had a linear, and now we're going to have the next pair of two quadratics. So basically we need to know that quadratics factor into a linear times a linear, and these are leading factors of 1, leading coefficients of 1, so that break apart those ends to n and n. And now I'm basically looking at the factors of 9 that when multiplied make 9, but add to make this 10, so that's plus 1 and plus 9. So that gets me 10, and multiplied gets me positive 9. And then in the bottom, okay, so in the bottom I have the same thing. I have a quadratic with a leading coefficient of 1, so that breaks into n and n. And now I'm going to take a look at the factors of negative 8. So obviously I'm doing these in my head, that when multiplied make negative 8, but add to make negative 7. And that is going to be negative 8 and positive 1. So when you take negative 8 and multiply it by positive 1, you get negative 8, but when add, you make negative 7. So now look what you have. You have identical factor pairs, and your factor pairs are going to be this n plus 1 and then this n plus 1 here. So they reduce with one another and they cross out, and you're now done. So except you just got to write your final answer. So your final answer is n plus 9 divided by n minus 8. Now, be careful. Some people like to go too far with this, and they like to cross these n's out because they see, oh, I have a pair of n's. So what you need to remember, though, is that quadratics have linear binomials as their factor. So this entire expression is the factor. N plus 9 is the factor, not just the n plus 9. So n plus 9 does not match n minus 8, therefore we can't cancel them out, and then we're done. This is my final answer. And that's it. So let me know if that helped.